Hello YouTube, this is ETRU, and today's video is going to be an E as an experiment. So today we're going to do the experiment of electrolysis of copper sulfate pentahydrate solution. So copper sulfite pentahydrate is this blue looking powder thing, and it's usually used for crystal making, but today I'm going to break the molecules up using electricity. So first I'm going to show you the basic chemistry of how it works, and then I'm going to do the actual experiment. So basically, copper sulfite is Cu. Wait, I think I'll zoom this up a bit. Zoom. Yes. Oops, out of focus. No, you can't focus while zooming in. Okay, I'll zoom it out. Well, I think you can see it anyway. So CuSO4. So obviously Cu is copper, S is sulfur, and O4 is just oxygen. And so in electrolysis there are two parts, plus and minus. So plus, the electrode connected to the plus side of the power source is called an anode, and the minus in the electrode that is connected to the minus side is called the cathode. So the chemical processing of the anode side is this. So anode, and so 2H2O in liquid, and that is turned into O2. This is gas, plus 4H, so 4 hydrogen atom ions, plus ions, and this is in a solution form, and plus 4 electrons. And on the cathode side, which is to say the minus side, so let's write cathode. So this is plus, and this is minus. Oops, minus. And so the copper, which is in a solution form, Aq, and plus 2 electrons, turns into copper in solid form. So the 2 plus ions meet the 2 electrons, which is minus and plus, so they cancel out each other and just form copper. And so if you do a chemical calculating and match the number of electrons and atoms, you get this: C2Cu, 2 plus ions, plus water molecules, equals the oxygen gas, plus 4 hydrogen plus ions, and 2 copper atoms. But we've forgotten something. Where did the S and O4 go? So we just add that to the calculation, and the total calculation is thus. So 2CuSO4 2 plus 2H2O equals O2, so that's oxygen gas, 2Cu, and 2H2SO4 plus ions. So this is the oxygen gas. Oops. Oxygen, and this is copper, and this is, my friends, sulfuric acid, the dangerous kind. Yes, sulfuric acid. The hydrogen inside the water and the sulfur in the copper sulfite combines to make a solution form of sulfuric acid. So we're going to do an electrolysis experiment of copper sulfite solution. So I'm going to put this in water. So we get this plus water. You get oxygen gas, copper in solid form, and sulfuric acid solution. So we're going to do an experiment right now. So first, I've introduced the chemical process, and now the ingredients needed are thus. So of course, the main ingredient, copper sulfite. This is in the pentahydrate form. So this is blue, as you can see. And then you need our cathode, which you remember, which you probably remember is connected to the minus side. And I'm going to use a solid pure piece of copper. So the copper solids that are going to be formed in the electrolysis experiment are going to stick to this. And then you need an anode, but for the anode you need something special. When you use carbon foam in anode, most people, sorry, I said something wrong. So most people use carbon as an anode for this kind of experiment, but carbon can corrode over time in this experiment. So I'm going to use something that is not at all very reactive with other elements, and that is, my friends, pure gold. So this is a pure gold bracelet I got from my, I don't know, first birthday or something. And no harm will come to the gold, otherwise my mother will kill me. Yes. So this is pure gold, and you can see that this is some kind of paint over it, but it's not paint, it's just gold to a different sheen. It's just gold, not matted gold, I think, and this is perfectly sheened and shiny gold. So it's just gold, and it works. And then you need wire. As you can see, I connected it already to the piece of gold, and our power supply, which is what? Wait, you can't see it. I'll raise the camera up a bit. Yes, a lantern battery, 6 volts, and I've already connected the cathode to the minus side and the anode to the plus side. And by the way, I just told you that this experiment will result in oxygen. Oxygen will come out of the gold, so that's why I said the gold won't be harmed. If copper came out of the gold, I won't use gold at all. I will just use carbon. And then you get the copper, which will be stuck to the electrode. Sorry, cathode. And the sulfuric acid will be just in the water, which and you'll see the water will turn clear over time. So I've already prepared a bit of water. This is about 250 milliliters. So I'm going to raise the camera angle like this, and I'm going to use this. Wait, you can't see it well, can you? So no, not like this. I'm a very amateur. No, wait. This is not working for me at all, and it's out of focus as well. So at least it's in focus. Yes, so I'll just do a camera angle like this. Zoom it out a bit. Very well, you can see it well. No, wait, I think I'll just raise the camera angle. Yes, now you can see it perfectly. So, first of all, you need the copper sulfide. So this is about 40 to 50 grams, and so it'll be perfectly soluble in 250 milliliters of water. So I'm just going to put it right in. Oh my god, it's turned straight blue. And I'm going to mix it up using a pure aluminum stick. This is pure aluminum stick. The light source is going out of the way. So I'm gonna fast forward. No, I just don't think I need to fast forward this part. No, I think I will fast forward this part. So I'm gonna mix it up until it's completely dissolved. So this aluminum stick won't do. It's too thick, so I'm just told my brother to get a small piece chopstick. So I think I'll be back when it's completely dissolved. So end of video right now. Okay, so it's completely dissolved now. It's taken 3 minutes. So anyway, so I'm going to put this is a cathode in. and the anode. And I believe it's working, yes. Already there's bubbles. You can see it. Bubbles, which means that the oxygen is already forming. Yes. The oxygen is already forming. Yep. Oxygen is already forming and the battery is hot. Yes, you can see bubbles. Definitely bubbles. You can see a lot of them. And I think I'm going to zoom in here. Yes, you can hear the sound. It's bubbling like crazy. And I better take the anode and cathode away from each other. Yes. So this is the oxygen liberating out of, you can't see it. Anyway, I just said oxygen will be liberated out of the anode and copper will stick to the cathode. Yes, my brother is explaining to my mother what I'm doing. So it's not zoomed up on the beaker, it's zoomed up on the anode, which is the gold, and that's good. You can definitely see the bubbles very clear. Yes, it's focused on the cathode and anode, which is a good thing for me. Yep, no, it's completely focused. And so now this will be the part where I'm going to fast forward for like an hour and 30 minutes or so. So I'm going to pull out the anode and cathode when the solution has turned clear as water. That means the copper sulfate will be completely used up. So yes, so okay, I won't talk anymore, and now it's fast forward time. So I think I'm going to fast forward for about 64 times. Okay, so watch. Hello guys, I'm back, and this is only the middle stage of the whole electrolysis experiment, and I had to move it from the beaker to this cup because I tried gold for an anode first and then it turned black. But I hurriedly sanded it down to expose the true color, and then I used carbon, as in pencil leads, but that too dissolved into the water and corroded, so I had to use a tissue and remove the floating carbon shrapnels. So this is a very clear liquid, and I'm instead using a chopstick, metal chopstick, and it works very well. But I think it'll turn black soon enough. So the gold was unharmed, but I didn't like using gold very much. It's expensive, and if anything that goes wrong, the blame's on me. So I'm using a metal chopstick instead, but this way you can see it a lot better. So the beaker was a failed try, and now I think I'm on the right track. So from now on it's going to fast forward. Hello YouTube, I'm back, and after 14 hours of electrolysing copper sulfite solution. I think the experiment has half succeeded and half failed. So obviously, as you can see, the copper grew, yes. So copper ions stuck to the original copper cathode, and as you can see, it is the copper. So extracting copper from the solution, I think, was a success. And of course the bubbles from the anode suggest that it was oxygen, and that succeeded too. But the problem is that the original sulfuric acid that we wanted is still blue. It didn't turn clear. And during the electrolysing, the battery, which was our original source of power, failed. So I demolished the battery and put out the zinc casings. I know a zinc because I saw a video from the King of Random, and he said that this casing was entirely pure zinc. So if this is sulfuric acid, or partly sulfuric acid, it should react with the zinc. So let's see. Yes, it is reacting quite nicely with the zinc. And the zinc casing, where the supposed sulfuric acid touched it, has turned completely black. I don't know why that is. So I'll try electrolysing this more with another battery, or maybe more batteries connected. But I think I'll try this again at a smaller scale. So preferably with this jar instead of this plastic cup. So one of the reasons I think I failed is because some element of this plastic combined with the sulfuric acid that was forming here and turned green turquoise. In the screen it looks blue, but to the eye it looks a very clear turquoise. Or I moved this solution from the beaker to this plastic cup using tissue. Yes, I filtered out the carbon dunk with tissue, so some molecule or element that was in the tissue reacted with the sulfuric acid that was forming and turned turquoise. But I think I'll try it again in this jar. It's glass, so it won't be very reactive. And for the anode, I think I will be using lead and tin. This is a piece of, I think, 63% tin and 37% lead, and I melted it using propane torch. So I think I'll be using a melted version of this for an anode, and I will put up a video of making an anode by melting this metal. So later today I'll be uploading the video. So this, the electrolysing of copper sulfite, attempt 1 is a half success and half failure, but at least the copper is cool. Yes, I'm very satisfied how the copper turned out, but I think I'll be trying to electrolysis this more, because the added copper is barely 1 gram, and I added 40 grams of copper sulfate, and CuSO4 means out of 6 atoms there is 1 copper. So even though copper is very light compared to oxygen or sulfur, it should at least get 5 grams, but there's barely been 2 grams increased. So I think I'll be trying this more and try a smaller version. So I'll come up when so my next video will be of melting this metal. Wait, it's out of focus. Melting this metal, and my second video will be of my second attempt on the copper sulfide electrolysis. So thank you very much for watching, and I'll see you on my next video.